in this diagram, you can see there is a mass. Mass is suspended by a string from a ceiling, from the roof. Then here the question is, what is the tension in this string? Tension in this string. So tension is a confusing topic for some of the students. So first of all, we should understand what is tension. Tension is basically a force only, right? It's a force which is acting. It's a stretching force. It's a pulling force which is acting within a stretched string, stretched rod, or anything. Okay, so here the question is, what is the tension which is acting in this string? So here it is given that the mass of the body is m. If mass is m, you know that the weight will be what? Mg. Weight will be mg. So tension means what is the total force which is acting on the string. So here in this case, you can see that the entire weight of the body, entire weight means it is mg. That weight is balanced by the string only. That means the string is holding this body. That means the force which is applied or which is acting within the string, that is called the tension, and the tension will be clearly equal to what? Mg. So T is equal to mg. Okay, so this is a very simple question. What is the tension in such a situation? Means you can easily write tension is equal to mg. But students, in this session, we are going to discuss how to find the tension at different points in a string. At different points, what will be the tension? So there is a chance of a doubt. If tension is mg here, will it be same at every point on the string? See, I'm just marking 2 points here. Look at this. This is point A and this is point B. So I have written T is equal to mg. So question is, what is the tension at A? What is the tension at B? Both will be mg or different. So students, please note that if the string which you are considering is massless, that means if you are not considering the mass of the string, then the tension will be the same throughout. That means here in this diagram, if you are ignoring the mass of the string, we can say that tension at A is equal to the tension at B, and it is equal to mg, right? So in this session, we are going to discuss how to find the tension at different points if mass is taken into account. If the string has mass, then I already told you, like, if a string has mass, the tension will be different at different points. Tension at A will not be equal to the tension at B. Then if you are considering the mass of the string, then how to determine the tension at different points, that's what we are going to discuss now. Okay, so listen. So we can consider such a situation. Listen, all of you. This is the roof, the ceiling, and a string is attached to it. This is the string, but here we are going to consider the mass of the string. Okay, mass of the string. Let the mass of the string be small m, and I'm going to attach a mass here. See, an object of mass is attached. So let us write the data here. Mass of the body is we can take it as capital M, and the mass of the string as small letter m. Okay, this is the ceiling. So students, please note that if mass is if you are not considering the mass of the string, then the tension will be the same throughout. Everywhere the tension will be same, and of course that will be equal to the weight of the block or the weight of the mass which is attached here, that is equal to what? Mg. But here mass is there. You can see what is the mass of the string. It is small letter m. Then how to find the tension at different points? So first step is we have to fix a point where this tension is to be determined. So I'm taking any point, for example this. So this is my point where the tension is to be determined. So I'm taking that point as A. Okay, so what is the tension at that point? The tension at that point A. How to find it? Students, listen carefully. You know that if there is a massless string attached and mass is here, m is here, then what is the tension? We already found that tension is equal to mg. That means we have to find the mass of the body which is suspended by the string into g will be the tension. Okay, but here we are going to find the tension at the point A, tension at the point A. That means you can split this string into two parts now. So listen carefully. I'm going to redraw this diagram. Look at this. See, till A, one part, till A, one part, and then after that, okay, there is a string, and this mass is attached to that string. This mass is attached to that string. So I'm just redrawing this situation like this. So this is capital M. So definitely its weight will be mg. And we are going to determine the tension at A. Tension at A means you can see that we are going to find the tension at this part. This part. Is it clear? So how to find the tension at that part? Come back here. Tension in this string is the weight of this much part, because this string is massless. So if you are applying the same logic here, how do we find the tension of that point A? It will be the weight of the part which is balanced by that point. So from the diagram you can clearly see that, listen here, you can clearly see that this much part is balanced by that point, right? This much part of the system is balanced by that point. So the tension at A will be the weight of this much part. That's a simple idea. So if you can find the weight of this much part of the system, that means a part which is circled, this much part of the system will be the tension at that point. Okay, so the question is, how can we find the weight? Okay, weight of the block is mg, not small mg, it is capital Mg, because mass of the body is capital M. So look at this, it's mg. This is the weight of that block. But apart from that, in addition to that, we have to add the weight of this much part of the string as well. Then only we will get the tension at that point. Hope the idea is very clear. See, if the string is massless, tension is equal to the weight of the body which is attached by the string. But if mass of string is taken into consideration, then the tension will be different at different points. Okay, so first of all, you can see, let's come back to the question. We are going to find the tension at A. I already told you tension at A will be equal to the weight of this much part. Okay, this much part of the system will be equal to the tension at that point. Okay, now listen here. A is our point under consideration. First, the string. What is the mass of the string? It's m. Now take the length of the string also. Length of the string, take it as what? L. Small letter L. So there is a string, its mass is small m and its length is L. Okay, and we have to find the tension at the point A. So we have to mention where is A. Where is A? So for that, we can take one more parameter. Let us take the point A is at a distance x from A. So at a distance x from the point of suspension, what will be the value of tension? That's what we are going to find it. Okay, so what we need is the weight of this part, right? That will be the tension. What is the mass of the block? It's capital M. Let's take the mass of this much part of the string as m dash. So what will be the total mass of this part? It will be capital M plus m dash, capital M plus m dash, right? So surely we can write tension is equal to, I told you, like, it is equal to the weight of this much part of the system, that is capital M plus m dash. That means that is the mass of that part of the string into g. So here the only unknown part is what? M dash. So if you can find m dash, that means the mass of this much part of the string, you can easily find what? Tension. So how to find m dash? Okay, so all of you listen, this one I am taking as equation number 1. I think this idea is very clear. How to find? So if they are giving some other point, for example, the point is here, then you have to consider the weight of this much part of the system. Okay, so here A is a point which is given here, so that's the reason why we are considering this part of the system. Okay, how to find m dash? For that, let's come. What's the mass of the string? M. What's the length of the string? L. Mass is m, length is L. That means in L meter, L length, there is a mass m. For L meter, m kilogram means, then for 1 meter, how many kilogram mass will be there? We will call it as mass per unit length, right? So, if you listen here, mass per unit length will be equal to, for L length, m meter, then for 1 meter length, it will be m by L, right? Very simple idea. So if you are considering 1 meter unit length of this string, its mass will be how much? M by L. Clear? So the idea of mass per unit length is m by L. We will call it as linear mass density. Leave it. We can just take it as mass per unit length. In 1 meter of the string, what is the mass? Is clear now? Right. Now what's our aim? Our aim is to find m dash. What is m dash? M dash is this much part per unit length, per 1 meter, how many kilogram of mass is there? M by L. For 1 meter, m by L. And if it is 2 meter, it will be 2 into m by L. 3 meter, 3 into m by L. That means if you know the length of the string, length of the part of the string into mass per unit length will give you the mass of that part. Hope it is clear. So if you can find the length of this much part, that length into mass per unit length will give you the mass of that part. Right. Now check the diagram and tell me what is the length of this part. Total length of the string is what? L. Total length of the string is L, and from the point of suspension to the point A, the distance is x. From the point of suspension to the point A, the distance is x. So total is L and this is x, means what will be the length of the remaining part? Remaining part means from here till here, right? It will be clearly, it will be equal to L minus x. L minus x. So we got the length of that part. That part of the string is L minus x. Is it clear? So L minus x is the mass of, length of that part. Therefore, we can write mass of the part of the string. That means the lower part of the string, right? Part of the string. That is m dash, right? M dash. Our aim is to find the value of m dash. So m dash is equal to length into mass per unit length. What is length? It is L minus x. L minus x into the mass per unit length. What is mass per unit length? Mass per unit length is m by L. M by L. That's it. We got the mass. We got the mass of the part. Mass of the lower part. This many part of the string is m dash, which is equal to L minus x into m by L. That's clear now? Right. So that is the only complicated step here, how to find the mass of that part. Once you get the mass, we can easily find tension. Let's go back to equation number 1. Equation number 1 now can be written as T is equal to M, capital M, mass of the block, which is attached, plus m dash. What is m dash? Look at that. M dash is, so we can write plus m by L into what? L minus x. L minus x. This is the total mass of this much part into G, right? Into G. That's it. Into G will come. Okay. So I'll be writing it once again here. So T is equal to capital M plus small m into L minus x divided by L into G. This will be the tension at the point A. So from that equation you can see that tension is a function of x. All other parameters are constant, like m, mass, capital M is a constant, mass of the block, small m, mass of the string, it's a constant, length of the string, it's a constant, G is a constant, but x is a variable. X is a variable, which means as x varies, as the distance varies, right? As distance varies, what will happen? Tension will also change. So you can clearly understand, if mass of the string is taken into consideration, the tension will be different at different points. The tension will be different at different points, and this is the idea to calculate the tension at any point of a string which has mass. Okay, you can try questions based on it. I hope this concept is very clear. So see you in the next session with another topic. Thank you.